Hey everyone, today we are going to look at LeetCode problem number 433, minimum genetics mutation. So let's directly go to this question. So in this question, we have been given a start and an end, and we need to find out how many mutations will be required to convert this string, to convert start to end. So what exactly is this mutation? So mutation is a change. So if we have this string a, so the mutation is like when we change a string by one. So in this case, like this can be one mutation, but like there is nothing changed, so we will just neglect it. There will be one mutation where we have changed the second character. So this is one mutation. Now in the third part, like we have changed this b, so this is one another mutation, and in this we have changed the last part, which is b. So this is one mutation. So this was the mutation part. So in our question, we have given the string as a c g t. So we can convert our string from like we can change our string to a c g t, like whatever we want. So if we are having this string age a, so how many possible, considering we can change this to ACGT. So what we can do, we can have this string AAAA or CAAA. You can see like we have changed the first part. So we, this is possible, this is possible, this is possible. And similarly, in the second I have changed. So you can see AAA is possible, uh, ACCAA is possible, AGT is possible, ATAA is possible. So similarly, like we can have changed in the third index and the fourth index. So these will be the changes if we are having, if we are given ACGT as our changing parameters. So in this question we have been given a bank also. So what exactly is the bank? So bank is containing all the set of valid strings which we can have. So let's see. For example, we are having this a as a string, and we know we can convert like the valid possible ways we can convert this string a is to AAA or CAA or GAA or TAA, or like one of these we can have that. And in the bank it will be defined which one we can follow. So uh, out of all these possible ways, the only valid thing here is I can see AAAT. So this is the valid one. Then AACA. This is the valid one. So these are the two possible, two valid genes we can have, and from these genes we can again make a gene which can be consisting of, which should be in this one. So for example, after we make AAAT, then again we can make a string and that will be present on the bank. If that will be present on the bank, that is also valid. For example, from AAAT we can make AATT, and if AATT is already present in the bank, so this is a uh, valid gene we can make. So let's look at some example. For example, we are having this start as AAAA and our end as ACAC. Okay, and so we need to make this string AAAA to AAACAC. So what are the possible ways we can do that? Like, so first of all we need to find out the genes. So for AAAA we can have either AAAA or CAAA, like we have seen in the above. So we need to check which one of these are valid. So we need to check the bank. So in the bank we can see CAAA is valid. Yeah, so we can process this one. We can, like, this is one possible way. Then we have ACAA, and ACAA is also there. Then we have AAAC, which is also there, but ACAC is not here. So this is one of the things which you can follow. So if we look into the answer for this, so we can follow this approach. We can convert AAA. This is our initial string. We can convert this. We can change the second parameter, which to ACAA, and it's also in the bank, so it's a valid change. And after that we can change it to ACAC by changing this A to C. So since it's a valid, so it is possible. And at the end, like we wanted ACAC as our answer, so the total changes will be 2, so our answer will be 2. Let's see the example which are given in the lead code. If we look into this example, we need to make this string as this. So we need to figure out how many changes will be required. So again, um, like what we can do, we can check. I mean, we can find out all the ways which we can change this string, and there will be total 32 ways. Why 32? Because we can change, like we are having this string as 8, and for all the string we can change it to 8, like either, like it can be either A or C or G or T. So there are 4 possible ways, so there are total 38 possible ways which you can change this string. And we need to list down all the possible things, and we need to check whether this string is present in our bank or not. So I can see one part which is present, which is A. So you can see we have changed this A to C, and this is present in our bank also. So this is one way. After that, C, 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 C. So again we can change this A to C, and it's also valid gene conversion. So you can see it's here, present here. So like for this our answer was 1. For this, like we have done 2 changes. Now we can change this A to C, A, C, 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 A, C, 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 and this becomes our end string. So till here we have changed three genes. So total 3 genes will be required to form this string. So what are the observation we have made here? So we need to make a string, and from that string we have to find out all the possible ways which we can convert this string to further genes. So we have to make all the combination for A. For example, we are having, if we are having A as string, so we need to figure out all the ways for that string. So when we have made all the changes, we need to check whether this is present in our bank or not. If those changes are not present in our bank, then that means like we can't make our string equal to end, so we will directly return -1. And if that is present, so we need to further keep on checking till our answer becomes the end. So I hope this clears some explanation. So let's see how we can code this thing out. So what I've done, I've taken a result variable to store our result, and we are taking hash set. So why I'm taking hash set, I will tell you later. But like initially what I'm doing, I'm just putting all of our elements in the hash set. For example, we are having this example here, which is this. So we'll put all these elements in the hash set. So I have added all the element in this hash set. Let's see why we are taking. After that, what I'm doing, I am doing the breadth first traversal here. So what I will be doing, I will be finding out all the ways we can make genes for this string. So I will list down all the possible ways. So after adding elements in the set, what we are doing, let's skip this part right now, and let's directly jump into this part. So here what we are doing, uh, we have a string and we are taking all the combinations. So this is the function where we can make the combination. So this is simple. We are just we have A, C, G, and T, and we are making all the combinations for this string. Um, After we got the combination, we'll store this in some array, and then after that we will check whether this string is present in our hash map or not. If that is present in the hash map, what we'll do, we'll add this in a queue. So for example, if we are having a in this like like our string is a, and AAAC is present in our map. So what we'll do, we'll make a queue and add AAAC in that queue. Okay. if our in our map A is also present, we'll add that to ACAA in the queue also. And after that, like uh, we will keep on getting. So here what we are doing, we are just getting the element out of the queue, and we are checking whether the queue which we have written is not equal to our end or not. If that is equal to end, we will just return out the mutation. So let me show you like what is exactly in the pair. So in the pair we have the gene and the number of mutations, and initially we have started with 0 as our answer, and every time when we are adding these values, whenever we are finding such pairs, so we are just adding one mutation here. So at the end we will just return -1 if we won't be able to find this. So this was about the coding part, and I've submitted this and it was getting accepted and it was pretty efficient as well. So see you in the next video. Thank you for watching.